Hi, this lesson is all about how the moon formed and how it's uh, closely related to the processes that were going on in the very young Earth, and also how those processes went on to create a planet that we can live on. Now, if you're watching this video, you should already have watched the first 15 minutes of a program called Catastrophe. The link to it is in the lesson guidance notes. If you haven't watched that video already, stop this one now and go and watch that video. We're working on page 21 of your Theme 2 booklets. You'll see there's a QR code and a website to find that video, or you can click on the link in the guidance notes. Okay, once you've watched that video and had to go answering the questions on page 21, let's see what information we can gather from that. The first question asked how many planets are thought to have orbited the Sun as the Earth was forming. So we should by now have had to go answering the questions on page 21. If we have a look at some of the answers to those, the first question asked how many planets there were. We now have 8. At the early stages of planet formation, though, we think there may have been 20, one of which was the early Earth. The second question asked about how the Earth's surface was different. It sounds like a pretty grim place, hostile to life. This is before life evolved. It's barren, it's lifeless. The atmosphere was made of toxic gases. There was certainly no water at the surface, nor was there any oxygen. Now, reconstructing the early Earth is a difficult thing to do. The features that we use as geologists have all been recycled. So we have billions of years of rock cycle processes, erosion, volcanic eruption, continental drift, all of which renew the Earth's crust. So if there is any evidence, it's going to be extremely fragmentary. The oldest rocks, for example, we have on Earth are about 4.2 billion years old. Now that's really old, but that still leaves us, 350 million years of missing history. So if we want evidence for this, we need to look elsewhere. The Earth doesn't give us evidence of its early history. Where we can find this evidence, though, are other planets. Mercury and Mars really have hardly changed in billions of years. We see the impact craters. We see the other features that we've been studying throughout this topic that haven't had the same amount of rock cycle processes. Their crusts are inactive, so they don't get covered up. So we can study those to tell us what must have been happening on Earth. Finally then, this catastrophic event that they were describing in the program is where a planet the size of Mars, so that's about half the size of Earth, that we call Theia, collided with the Earth. They're orbiting at the same distance from the Sun and crashed into each other at 25,000 miles an hour. That debris that would have been thrown out formed the Moon. One of the effects of that impact was to tilt the Earth on its axis, which gives us our seasons today. It had a profound impact on the composition of the planet, crucially the size of the planet, the fact that we have a magnetic field, the fact that when we can have enough heat to create an active crust, which gives us an atmosphere, the list goes on. It's an incredibly important event in making Earth as special as it is. Okay, there's one more video I'd like you to have a watch of. The link to it is in the lesson guidance notes. It's to look at a mission to go and study one of these other planets. This is an image of Mercury. And a mission called Bepi Colombo has been launched back in 2018 to go and study the planet. It's on its way as we speak. Watch the video, see what they're hoping to find out. See how that relates to really what we've been talking about. So, to conclude, our Earth is unique. We know of no other planets like it. The mathematics of probability suggests that there must be other ones out there, but we don't really know. We haven't found one yet. One of the things that makes our planet unique is our moon and the size of that moon, and also the knock-on effects of this impact that happened at a very early stage of the Earth's formation, of which the moon is part. It's a fascinating story, and one that I think gives us an indication of just some of the chance geological events that have happened that allow our planet to be as it is today. Okay, we're getting towards the end of the theme. Next time, we're going to have a look at how this theme might be examined. I'll see you then.